Hey, fifth grade, welcome to National Teacher Appreciation Day. Oh, I do feel appreciated often. In a strange way, I'm going to appreciate you. Actually, and I think that's the mark for all teachers. It's a vocation, and the only reason we do it is because of the great appreciation we receive from you as students. So in a weird way, you can thank me and you can appreciate me, but it furthers and increases my appreciation for you. Because of that, I thought it would be a great idea to give you half homework. So this is going to be HW96 falling on a Tuesday, the day that we choose, and I choose to give you half homework. So only do the evens tonight. I'll make sure that that's posted on Google Classroom. We're going to be looking at solving problems involving integers. So let's dive right in. First, let's define integers. We've defined it before. Remember, integers are the whole numbers and their opposites. And basically, when we think about integers, generally we're probably thinking about the numbers that we would see on a number line. And we're going to draw a number line. But remember, integers are the whole numbers and their opposites. So if I drew a number line, boom, boom, arrows, don't forget, and I smacked 0 right in the middle, let's say I went tick mark, tick mark, tick mark, tick mark, big tick mark, and then over on the other side I'll do the same tick, 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 big tick, big tick. And then I name those numbers. I would name what? I would say, okay, to the right of my 0 are my pauses. That's 1, 2, 3, 4, and then the big one's 5. And then on the left, we know it would go -1, -2, -3, -4, and -5. Clearly, when we look at a number line, we are looking at integers, 0 included, even though 0 doesn't have an opposite. It is considered a whole number. And we know that how number lines work is everything to the right of 0 we consider positive. And everything to the left of 0 going that way we consider negative values. Not every value is an integer, though, because remember, integers are only things like -1 or -3. They're not things like 2.5 or -3 7/8. Yeah, so that's just one thing we want to establish. Let's jump into some of the problems they're going to give to us. Here's one. I know this will take a little while, so if you need to pause me before I get going, but I do want you to draw that little temperature gauge. It can't be loose, though, so we're going to be looking at that temperature gauge. So why don't you hold off on the temperature gauge real quick, and I want you to write down the statements in green and blue and black. The high temp was 6 degrees centigrade or Celsius. The low temp is shown, and we're going to draw that in a moment. And then the degree difference between the high and the low is the question. Now notice my temperature gauge it's actually a number line. It's a number line that shows both positive values, such as the 10 degrees, and negative values, such as the -10. And you see the little markings I've made. All that is quite careful. I'm not just making little lines. If you notice, there's 4 little green markings in between, let's say, the -10 and the -20. And that represents the spaces. So there's 1, 2, 3, 4, 5 spaces. Therefore, each one little tick is worth 2. And so if you haven't drawn this and it's not careful and you haven't written everything, you should pause. Just pause and draw it all down. But I'm going to go ahead and start. So it says the high temp was 6 degrees, and it says the low temp is shown. Well, what is it showing right here? I think we'd have to conclude that if those increments go by 2s, that is -12 degrees centigrade or Celsius, right? So if it's looking for the degree difference between the 6 degrees Celsius and this -12 degrees Celsius, and it's asking for what we call the difference. Well, difference should lead us to one operation only, and that is subtraction. So what I'm going to do is I'm going to take my big, the 6 degrees, and I'm going to subtract it from the small. And again, that small is -12. So I'm going to wrap that in parentheses. Oop, we've seen this before. What's that called? Who can tell us? Okay, go ahead. Yes, you. Yes, you. You can put your hand down. I'm calling on you. Good. The inverse of the inverse. And so if that's the case, we're going to go plus plus, as we learned. And then we'd say, okay, well, 6 plus 12, we know that is 18 degrees, or 18. And we're answering this question, we'd have to say, oh, there's an 18 degree difference between the two temps. We could box that up. Yeah. So that's something I want you to be able to make your way through, if you will. Hey, let's look at another. Go ahead and write this down. There's a guy named Rick. He has a checking account. It has a balance of $7. If he writes a check for $10, what integer represents his new balance? Again, please write this all down. When thinking about integers, we want to be able to look at real-world situations, such as banking accounts, and determine, well, what is positive and what is negative? Right here, it says that he has a balance of $7. The balance represents the money he has in that checking account. So that would be described in a positive way. It's what he has. So that's a positive 7. Now, writing a check for $10 is actually kind of the opposite. The way that checks work is I can write on a little special piece of paper a certain amount and hand that to someone, like maybe for food or rent, or I'm paying them back for whatever reason. And that check is worth money. It's worth cash. And so when I write a check, that's actually a negative sort of idea because I'm losing that money. So that $10 check represents an integer of -10. So then it says, okay, what integer represents his balance? Well, again, if I started with positive 7 and then I added to it -10 or I subtracted 10, then I want to ask myself battle questions. So is it a battle? Yes. Who's going to win? Hopefully you'd say the negatives. And then I'd ask by how much? And so -3. And I'm going to box that up. And I know what some of you are saying. You're like, wait, you can't box that up. This is money. I know, but think about what they asked me. They said, what integer? Well, -$3 is not an integer. Just -3 is. And so we like this answer because it's answering the way they want me to. It's saying what integer represents his balance. Now, clearly, we could say that he has -$3, which means he's in debt right now. Hopefully, he'll make more money and get it back into that checking account. Hey, let's look at evaluation. Go ahead and write it down. The one-word direction for this is evaluate. And then you see the purple expression, 10 minus, open parentheses, x plus 5, close parentheses. And then it gives us the value of the x. Now, we've looked at evaluation ever since the start. Now, remember, evaluation is a two-step process. First, I'm going to substitute. I'll just put sub. Remember, whenever we substitute, we use parentheses. Very key. Please always do that. Even if you go on to have other teachers, I think you should always use parentheses when substituting. All right, number 2, do you remember? Yep, good. We simplify. So let's go through step number 1. Remember, we're going to use parentheses, but first let's write down what's not being substituted. So this 10, I'll write that down. This minus, I'll write that down. Now, I'm thinking ahead always. And so I know that I'm not going to use parentheses here because I'm going to have to follow it up with parentheses. So this is where I'd move into, to represent these parentheses, I'm going to move into braces. No, sorry, brackets. I always make that mistake. Then I focus on that x, and because I'm substituting in, that's where I'll use parentheses. And what am I substituting in? Well, they told me that x is equal to -4. Close those parentheses, put a plus 5, close with my brackets. Now, again, I'll just do some rewrite. There's my 10, there's my minus. Now, thinking about what's going on the inside, that's a battle question. Is it a battle, right? -4 plus 5. Yes, it is a battle. Who's going to win? Well, we know that +1 will win. So I'm just going to now turn those brackets back to parentheses, and I'll say 10 minus 1. Well, again, what grade level can we bring in to help us with that? But 10 minus 1 we know to be simply 9. It is a battle. The positives win. They win by 9. All right. Now, last one, but we're going to do a couple things with this one. So this is called a function table. And basically, they're not giving us the function. They're asking us to kind of use our brain and go, okay, if the x is -2, the y is -3. And then they give us another full one. If x is 0, then y is -1. If x is 2, y is 1. Can we fill out this function table? Well, we would probably kind of take some time to think about what's called our input and our output. And looking at this first example, we see that our input is this -2. X values are always our input. And when we input -2, what we end up with is what's called our output. In this case, our output being -3. Yeah? So what's going on there? Let's look at the next one. So our input is 0. Our output is -1. What do you think's happening there? Okay, how about this next one? Input, excuse me, input 2, output 1. Well, that's probably the easiest one to start with. Because think about it. What's happening to my x each time? In that last example, my x is 2, So what's happening to the 2 to get to 1? Well, wouldn't it be subtracting by 1? And then actually I can write out this function and say, well, so y is going to equal that. Y will equal x minus 1. If you notice, it holds true for the other 2 examples too. So real quick, if we focused on like the 0 minus 1 is, negative 1. Or this negative 2, negative 2 minus 1. Well, that wouldn't be a battle. They joined forces, negative 3. So I can say y equals x minus 1, right? Now, if that's the case, I can plug in the ones I don't know. So you see here I have an input of negative 1. So if I plug that in for my x, that'd be negative 1 minus 1. That is not a battle. They'll join forces to equal negative 2. Therefore, that must be my output. Or for this one, the 1, if I plug that in for the x, it would say 1 minus 1, which we know is 0. And then that is that. Now, whenever we create function tables, we might have to do something else. Can you think of what it is? Good job. Yeah, we could graph. Because what these are coordinate pairs. So this first one is negative 2, negative 3. This next one is simply negative 1, negative 2. And then on down the line, boom, 0, negative 1, 1, 0, and then lastly 2, 1. So guess what? We get to graph today. Yay! Draw me up a coordinate plane. It doesn't have to be as big as mine. I do want you to get out to the 5Zs. You can see I've marked those 5Zs, not with numbers or anything, just a mark. When you have your drawing, if you want to pause me, that's fine. Get it drawn up. Use a trusty ruler. And we're using the boxes that are already available on your graph paper. But you can pause me now if you don't have yours drawn, but I'm going to go ahead and start. So the first coordinate pair they gave me was negative 2, negative 3. Well, I know I start at my origin and then I move over. So negative 2 on the x-axis is moving to the left twice and then down 3 because it's a negative 3, which would be right there, right? Okay, so my next one was negative 1, negative 2. All right, so starting at the origin, move to the left, that's negative 1, and then I go down 2, boop, right there. Okay, good. Next one was 0, negative 1, okay. So I'm not going to move off of my origin there to the left or right, but I am going to go down 1. That's right there. Okay, good. Next one, we had 1 and 0. So again, on my x-axis, I'm going to move over 1, and then I don't end up going anywhere because there's a 0 on my y, right? So 1, 0. And then lastly is 2, 1. So again, get out to my 2 on the x-axis, go up 1, and I put it right there. Now you might notice in this function that it's a linear function, meaning that all those points line up. And that's where you take your trusty ruler again, and you're going to line it up with those colorful points. They're colorful on my thing. Probably just look like monochromatic on yours. And you're going to draw a line that's going to look a lot better than what you're about to see. I cannot bring a ruler down to the iPad. Things don't work. So this is the best I can do, but yours is going to look so much sharper and cleaner because you're going to use a trusty ruler, but there's mine. And I can't forget my arrows. And I can't forget that this was a good lesson. Wow, they really made us think about a lot of things. I hope you are thinking about those things, that you're doing well. Guess what, kids? We're rounding up. We're coming up soon to that lesson 100. What a world to celebrate we live in. I hope you're well, and remember, you can reach out to me anytime. Remember, because of National Teacher Appreciation Day, I'm going to flip that script, and I'm going to appreciate you. And one little gift of my appreciation is you only have half homework, so only do the evens. Bye.